Hey everyone, so in this video we'll look at Poisson distributions and see how to compute different probabilities there. So a Poisson distribution is another discrete distribution, and we generally use it to express the probabilities of a certain number of, if we are interested in events that occur over a certain length of time or a particular interval of space, then we tend to use Poisson distributions. Things like number of cars at a joint, number of babies born in a hospital in an hour, number of calls received in an hour, and so on. So the Poisson distribution just has a single parameter lambda, which you see here in this inverted Y type Greek alphabet, that is lambda. And lambda is nothing but the average rate at which these events are happening. So for example, if I get 5 calls on an average in an hour, then the lambda is 5. If on an average 4 children are born in a hospital in an hour, then the lambda is 4. So once we know this parameter lambda, once we know that, we can find probabilities for a Poisson distribution with a given lambda. So let's look at a few examples. And the same prefixes D, P, and Q apply here as well, and we'll predominantly use D and P. So D stands for computing probability at a given point. P is for computing the cumulative probability. So let's begin. Suppose it takes me 10 minutes to grade an individual assignment, and I'm interested in finding the probability of grading X assignments in 1 hour. So this essentially is asking about X events in a given interval, which is 1 hour. And it fits the classic definition of a Poisson distribution, so we'll use 1. Now, the first step to solving problems with Poisson distribution is to understand and figure out what lambda is. Now, lambda is the average number of events that occur in the given interval. On an average, how many calls do you get? How many children are born, and so on. So in this case, lambda will be how many assignments I can grade in an hour on an average. So we're told that I can grade about 1 assignment in 10 minutes. And therefore, I should be able to grade 6 assignments in 60 minutes, which is an hour. Therefore, on an average, I can expect to grade 6 assignments in 60 minutes, so I can say that my lambda is equal to 6. So now we're ready to begin. Now, what's the probability of grading exactly 8 assignments in an hour? So this is P of X is equal to 8. Now, the particular term in which the function for Poisson distribution in R is called POIS, and we'll put the prefix that we need in front of the distribution's name. So we want the prefix D because we're looking for exact probability, and then we put POIS. So you see how it shows up there in the drop-down box. That's what we want. So DPOIS, open brackets. The first argument is always the particular X value. So that's going to be 8 for us. And the lambda value is 6. And you can ignore the third argument for now. And the answer for this is 0.10325. So that's the probability of grading exactly 8 assignments in an hour. What's the probability of grading at most 5 assignments in an hour? P of, so we want to find, give me a second. This is P of X being lesser than or equal to 5. Classic cumulative distribution function, so we'll use the P prefix. P pos, we're looking at X less than or equal to 5. So that's the value. For Q, you put in the number 5. And lambda is equal to 6. And we can ignore the other arguments for now. The answer is 0.44568. The last one, probability of rolling at least, sorry, this is not rolling, this is grading. At least 7 assignments in an hour is P of X being greater than or equal to 7. Because it's at least, we also include the value 7. And from just like how we did in our binomial calculations, this can be written down as P of X being lesser than or equal to 6. So I subtract everything from 6 and below from 1, and therefore I'll be left with everything 7 and above. So this is nothing but 1 minus P poise 6, 6. And enter, we get 0.39369. And that's how we've solved the first example. I'll do one more example and I'll let you do the final one yourself. So the second example speaks of a switchboard in a Minneapolis law office. And this particular switchboard gets an average of 5.5 phone calls during the noon hour on Mondays. It's pretty specific. So we're talking about number of calls at a specific time during the day. Therefore, Poisson distribution. Now, okay, so the second sentence is irrelevant. So let me just remove that. Okay, now we can model this using a Poisson distribution. So let's figure out what lambda is. Now, lambda is the average number of phone calls that they get during the noon hour. And we are told that lambda is equal to 5.5. And now that we know lambda, we're ready to begin. What's the probability that the office receives at most 6 calls at noon on a Monday? So this is nothing but P of X being lesser than or equal to 6. So the maximum is 6. It can also include values below. So this is nothing but P Poisson. 6 is the number of interest, lambda is 5.5, and that's all we need. The answer is 68%. That's the probability of at most 6 calls. What's the probability that they receive exactly 6 calls? This is easy. P of X is equal to 6. We use the B Poisson function. So here we're interested in 6. The lambda is 5.5. The answer is 15.7%. And the last one, what's the probability that they receive more than 8 calls at noon? So more than 8 calls will be X greater than 8. Note that we're not including 8 here. We're only looking at numbers 9 and above. So this can be written as 1 minus P of X being lesser than or equal to 8. So we count down, we count off everything from 8 and below and subtract that from 1. So we're left with everything above 8, which is what we want. So this is 1 minus P Poisson 8, 5.5, and the answer is 0.1056. So I encourage you to give this all a try and practice. And there's another question that I've left as an exercise for you. But let me put down the answers here just so that you'll be able to double check. So for the third question, the answer to this one is 0.21376. And then this one's answer is 0.757576. The third one is 0.04202. As always, you can also verify your answers in Excel as well as using the applet. Now, figuring out all of these statements is what you need to get more comfortable with. Once you're able to pin down the exact probability statements, then applying the function will be very straightforward and easy after that. So please give this a try and good luck practicing.